So today we're looking at lesson 4, numbers raised to the 0 power. And you already know that when we're dealing with numbers x and y, any positive integers, so we've just been looking at positive powers, that we have x to the m times x to the n. And you know that when you're multiplying the same base, you just add those exponents. And when we're raising a power to a power, that you multiply those exponents. And that when you have two factors raised to the same power, you can just share that power. So those are the three cases that we're going to be looking at in the examples to kind of analyze our next rule. So when you see the cases, this is what we're looking at on the rest of the sheet. So our definition for the 0 power is that for any positive number x to the 0 power is equal to 1. And we're going to analyze this using these three cases in the next part. So we're going to look at case A, where m is greater than 0 and n equals 0. And then case B, if m is equal to 0 and n is greater than 0. And then case C, if m equals 0 and n equals 0. So three different cases for that. So we look at if x to the m times x to the n, can we still add when there's a 0 involved? And that would be, x to the m, if m is just a positive number greater than 0, times x to the 0 if n is equal to 0. And that would be x to the m times 1, which is just equal to x to the m. And we can see that that still holds true for our old rule of being able to add the powers, because we would be adding m plus 0, which of course is just m. So having that work for that case just proves that rule of x is 0 equaling 1. Now if m is equal to 0 and n is greater than 0, then we have x to the 0 times x to the n. And following our old rule, that would be 0 plus n, which of course is just x to the n. And in order to get that, that really proves that just x to the 0 is equal to 1, because it does not affect the product. Then we look at case C, and that's if both of those exponents are zeros. So we have x to the 0 times x to the 0, and that would be 1 times 1, anything to the 0 power being 1, which is of course just 1. So in the next part, we're analyzing our raising a power to a power that we multiply when the 0 power is involved. And we're saying, okay, m is greater than 0 and n equals 0. So that would be x to the m raised to the 0 power. With our typical rule, then that's x to the m times 0. And we know that anything times 0 is 0. And that, of course, means that is equal to 1. So even when we're raising a power to a power, if that power ends up being 0, the final product is 1. So looking at that same case, if we have m is 0 and n is the one that's greater than 0, then we end up with x to the 0 power raised to the n power. And then that's x to the 0 times n, which 0 times n is going to be 0, and anything to the 0 power is 1. So we're looking at case C, and we have m and n both being 0, so that would give us x to the 0 raised to the 0 power, which of course is x to the 0 times 0. And 0 times 0 is 0, so we end up with just x to 0 power, and anything to 0 power is 1. So in the next case, we're looking at kind of our sharing of powers, that we can take each factor to the power when it's grouped together. And we're looking again at m being 0 and n being 0. So we would, this one is not involving the m. Right now we just have the n in the example, so we're not really looking at that. And we have x, y to the n. And if we have that n being 0, so that is going to be the same as x to the 0 times y to the 0, which is just 1 times 1, which is equal to 1. For case B, again, m being 0 and n being 0, but in this example not really using the m, we have x, y raised to the n power. This time n is greater than 0, so we're going to use that letter. And that's just really x to the n times y to the n. Same rule as before. We don't get 1 as the product here because we're not involving 0, and that's just a reiteration of our old rule. For case C, we have x, y, and then here we're looking at that being raised to the 0 power, as we're both m and n are 0. And this one's going to turn out the same as case A. We end up with x to the 0 times y to the 0, which is equal to 1 times 1, which is equal to 1.